Unit 12, Recording 32.
Today I'm going to talk about graphene. Now, graphene consists of a single atomic layer of carbon. As you know, carbon is the base for DNA and all life on Earth and can exist in several different forms. The most common form of carbon is graphite, which consists of stacked sheets of carbon with a hexagonal, six-sided structure. So, how do you make graphene? Have a look at this slide of a piece of graphite. You can see that they've sliced off 2 flakes or slices of graphite from the block, and there they are on the right-hand side. These are 2 10-nanometer flakes. Each one is 30 carbon atoms thick, or perhaps I should say 30 carbon atoms thin. Now, look at this next slide. Here you can see how graphene is made up of an atomic scale network of carbon atoms, and it clearly shows the six-sided structure of each carbon atom. When we talk later about transparency, you can understand why. The new material graphene has a number of interesting mechanical and electrical properties. It's naturally very thin. It's a transparent conductor. It's much stronger than steel and is very stretchable and flexible. The thermal and electrical conductivity are both very high, and it can be used as a flexible conductor. With new industrial fabrication methods, it's possible to fabricate sheets 70 centimetres wide. Let's come on now to some applications. Since graphene is a transparent conductor, it can be used in touchscreens, light panels, and solar cells. Among several possible applications for the future, we can include flexible electronics and gas sensors. In the future, new types of composite materials based on graphene could also be used in satellites and aircraft, mainly because of their great strength and low weight. I'll now give you some details about its specific properties. First, strength. Graphene has a breaking strength of 42 newtons per metre. Got that? 42 newtons per metre. Graphene is more than 100 times stronger than the strongest steel. Have a look at this slide of a happy cat in a hammock, or very fine net tied between 2 trees. You could place a cat weighing about 4 kilos in this 1 square metre hammock before it would break. This brings us to the density of graphene. Go back to our very fine net, or hammock, measuring 1 square metre and made from graphene. It would weigh 0.77 milligrams. Milligrams, not grams. The hammock, it's so fine it's almost invisible, would weigh less than 1 milligram, which is the same weight as one of the cat's whiskers. Makes you think. Next, optical transparency. Graphene is almost transparent, as we saw in the earlier slide, and absorbs only 2.3% of the light intensity. It's colourless. Conductivity. Graphene has a higher conductivity than copper. Thermal conductivity. Graphene conducts heat 10 times better than copper. I see we've got a little time left before the end, so are there any questions?